All right, this is our question 1. So F net equals 0, we said. This is Newton's first law. From here, people, as you see, how can we make F net? People, we are going to have two different calculations. First one, up and down. Okay, this one for normal force and friction force. How we are going to calculate friction force? For other questions, in other questions, you are going to see, people, friction force equals this 1 times coefficient number. This is constant number, different methods. It is constant number you will have during question, and then times F normal. So first of all, we should know how can we calculate normal force. Because of that, we are asking this kind of questions, people. We start with normal force. After that, people, what can happen? You are going to calculate friction force, and then you will have apply force. So we'll just carry on like that. But first of all, we should know how can we calculate normal force. I think everything is fine. F net equals 0 because object is not moving. And then what we have, people, F normal going up. We are choosing direction. Do you remember vector questions? We said choose positive and negative. If you use this side positive, other one is negative. So F normal positive minus Fg equals 0. And then Fg going other side, F normal equals Fg. Fg, we know, people, it is weight, gravitational force. Other name is weight. So weight formula is M times G, 5 times 9.8, 49, direction upwards. That's it. If you have any question, please ask me now on chat. Otherwise, we are going to carry on with other questions. This is our first question, first type of question. Today, unfortunately, I'm not asking you question to try. All types of questions I will try to show you about Newton's first law and second law. Okay, and then from next week, people, we can carry on with past paper questions. Okay, we have a question here. Upwards, can we say north? Yes, why not? Also correct. North, south, east, west, also we can use, people. For normal force, as you see, it's going up. You can say north. Why? Because we are looking for normal force. You have another question, why it is upwards? Because we are looking for normal force. As you see, direction showing up because of that. I think this is fine. Yes, thank you very much. All right. No more question, I think. We can go to question 2. These questions from your textbook, people. We are just explaining, all right? Please, you don't have to waste your time by writing down. So you have already all solutions, everything on your textbook. Okay, let's continue with next question, if it is okay. This is first step, people, please. Do you know, just we should understand how can we get normal force for this system, for other system, normal force. If you get normal force, after that, it's going to be easy, step by step. Because when you get normal force, you can calculate friction force. After that, when you have apply force here, for example, if you have apply force this side, let's say F apply we have, and then friction force just opposite to apply force, friction force here, and then you can get net force for parallel also. And then you can calculate acceleration. So normal force, friction force, net force, not this one, people. We have two different calculations for up and down, for y-axis and x-axis. So two different calculations, please. Don't mix them. All right. This is F net for up and down. It is 0. And then for x, F net, you are going to get. And then Newton's second law will come. After that, it will carry on. But first of all, we should understand how can we get normal force. I see there's no question. We can carry on. Question 2 now. Let's continue with question 2. Okay, so question 2, let's see what they are. All right, let's continue. Okay, now we have apply force, and then they're asking you people calculate normal force. Okay, not only gravitational force. It was our question. Other questions start with normal, what's that? Gravitational force only. But now we have apply force. For this kind of questions, how we are going to calculate, people? First of all, we have to calculate components of application, apply force. components of apply force. How we are going to make it? Let's draw here. First of all, for parallel one, F parallel, and then just going up, just like this, not over than that. Okay, anyway, F perpendicular. F perpendicular, we can say. You will see next slide already. It's fine. First of all, we are calculating components. Because of time, people, I cannot wait for your answers, but maybe you can try, but I'm going to show answers now. No, so sorry about that. Normally I was going to show answers, everything, but okay, it's fine. I cannot wait for you, unfortunately, because I want to answer more questions today about Newton's first law, second law. All right, this is also Newton's first law, but what's the difference from other question, people? Now we have apply force with angle. As you see, we have apply force here. First of all, you are getting F apply parallel, F apply perpendicular. So we are just drawing. After that, people, we are writing our Newton's first law one more time. How can we write it? F net equals 0. I think almost for all questions, you are going to see that Newton's first law, second law. When we go to Newton's second law, people, you are going to see F net equals m times a. But for now, F net equals 0. Okay, for up and down, if you are busy, up and down, people, just forget about parallel law. All right, we don't need for now. If you have another apply force here, then if you have friction force, if object is moving, if you are busy with Newton's second law, yes, you are going to use parallel one. But for now, you are just using up and down what you have. Okay, from now, what we said, people, use up positive, down negative. Okay, on top, which one going up? F normal and F perpendicular. I think it's okay. So F normal, from now we can use this one, people. F normal plus F applied perpendicular minus Fg equals 0. I think everything is fine, just starting from here. So F normal plus F applied perpendicular minus Fg is 0. From now, people, what are we doing? We are taking Fg this side because we are looking for F normal. Fg coming here is positive, you know, in maths. And then F applied perpendicular coming this side, it is negative. And you know, people, to get components, F apply equals, F apply perpendicular equals F times sine. Okay, for this kind of questions, it is sine. So we are looking for this one, F perpendicular equals F times sine angle. It is 30. I think it is clear. From now, just calculating. That's it. Also upwards or north, you can say. Are you getting it, people? We start without apply force. Question 1, only gravitational force. But now we have apply force. It's just pulling up. Because of that, as you see, adding to normal force. Another question you will see, people, different. But it's fine. This calculation, from now calculations. What are we doing, people? First of all, we are getting components. We are just drawing component, number 1. Number 2, we are writing our Newton's first law. If you have any question, please ask me. If you get it, it's fine. We can carry on with next question. Okay, let's wait a few seconds. If you have any question, please ask me now. I hope you are getting it, people. This is Newton's second law. People, when you go to Newton's, sorry, this is Newton's first law, Newton's second law. When you go to Newton's second law, to get friction force, you are going to use this calculation, people. To get friction force, you are going to use normal force. All right, because of that, it is very important. So we can carry on. I see there's no question. I hope everyone is fine. So next question is coming now. Let's clear all. Yes, similar question, but now apply force, pushing. It is not pulling anymore. Direction is different. And then asking you normal force. Maybe you can try now, okay, because I see you're getting it. So please try this question. We can give you a few minutes, because if you don't try, you cannot learn, people. And because we just answered too many questions, but please try this question. Similar question. Only what's the difference, people? If applied perpendicular, it's just going down. So direction of F perpendicular is different. Let's see from your side. I hope answer is coming, not get from your textbook. Eh? Please try. You have 2 minutes. Your time is over. Are you trying? Any answer coming now? We are looking for normal force. I cannot see you now. I hope you are trying. Yes, answer is coming now. We have one answer for now. Another answer, 2 answers now. That's good. Let's make one more correct answer, and then we can carry on. We can explain. We have different answer. 24,4 is not correct. Please double check, maybe calculation. Okay, but we need one more correct answer. Please try, people. Always I'm telling you, yeah, one more answer is coming here from boys now. That's good. Okay, we can carry on. So now we have applied force, but it is pushing. Let's go to, okay, that's good. So we can carry on with next question. Let's see our solution. All right. Now, first of all, you are getting components of applied force. As you see, pushing, both of them pushing. And then what we said, people, if you are busy with force with angle, so you must just get components first. After that, you must forget about parallel one, because we don't need. We are looking for normal force only. And then what we said, people, just choose direction, positive and negative. So this is negative. This is also negative, because you see it's going down, down, down. So what's our Newton's first law? F net equals 0. And then F net, which one positive? F normal. F normal minus Fg minus Ff perpendicular equals 0. I hope it is fine now. We just add something on your textbook, just this part is missing. So F net equals 0, F normal minus Fg minus Fy minus minus because of direction. I hope everything is fine. And then you are just taking this to other side, and then you are getting F normal equals Fg plus Ff perpendicular. Other one, do you remember? It was minus. This one is fine. You don't remember. Just remember direction and how we are getting, how we are writing an equation. From now, just calculation, people. 34,4 Newtons upward or north, you can say. I hope it is fine. I hope everything is fine. You are getting it. So far, we are busy with Newton's first law only. Newton's first law, all types of questions we are trying to ask. First of all, we start with only object, only gravitational force. After that, apply force, pulling force, and then pushing force, another one, pushing force. We just calculate our answer just normal force. Okay, we have done. Let's continue. Let's see what else we have. Next question. Okay, another system. Now it is going down. Object as used inclined system we have now. Not so this kind of questions, how we are gonna answer. Okay, we are looking for normal force. People, you will see, from now, just we are busy with first step of our questions. When you go to question, they will add friction force. They are gonna say object is moving. They are gonna add another object, but all same thing. All start from this point, all right? Start from normal force. But don't forget this one, people. If there is no friction, there is just you don't have to worry about normal force. You don't have to worry about friction force. If there is smooth surface, okay, if there is no friction force, it means normal force is 0. Normal force you can make just 0. You can use it as 0. Okay, let's continue. This question, calculate normal force if you have 10 kgs object. Let's see how we are going to calculate. First of all, we are drawing forces on object. Oh, this one is not clear. Let's go back. Let's draw. Okay. First of all, we have gravitational force. As you see, there is no applied force. There is no applied force. Only gravitational force we have. Only gravitational force. Let's draw. Gravitational force is going down. We have Fg. I think it's fine. And then what else we have? Of course, we are going to get components of gravitational force. Because now, as you see, coming with angle, components of gravitational force, and then Fg parallel, and then coming this side, perpendicular one, Fg perpendicular to surface. And where is our normal force? Also perpendicular to surface, but opposite direction to Fg perpendicular. This is normal force. This is our first step, people. We are just drawing components of gravitational force. But something is different here. What we said, Fg parallel, what was the formula? Fg times, for applied force, it was sine. Fg parallel, it was sine, but now you will see difference. Yes, I will share this one on Google Classroom. After this lesson, I will just share it. You will have this one. So, people, this kind of questions, how we are gonna get it? Do you remember we said, if you are busy with normal force, we have two different calculations, this way, up and down, but now inclined system, because of that with angle, it's fine. But if normal, Fg perpendicular, only. We are busy with these two only. Forget about parallel one. But what is the difference here, people? Fg parallel equals Fg parallel, it was cos, right? But now sine. Why sine? Let's try to explain with big triangle. So just everything for component. Let's remember for component first. F component, first of all, people, please remember this one for x and y axis. What was it? This is x-axis and y-axis, and then object, your force is here, F is here, and then you have angle this side, this angle. So F parallel, what was it? F times cos angle, and then other one, what was it, people? F perpendicular, or Fy you can say, F times sine angle. Which one close to angle? It is cos. But now you will see, people, Fg perpendicular equals Fg times cos angle. It is coming from maths, people. Just will explain to you now. Fg parallel equals Fg times sine All right, so you don't have to memorize details. I will give you some details now, but you don't have to know that. Just know if you have inclined system, just remember it is opposite to components formula, all right? Not cos anymore. Parallel is sine, perpendicular one is cos. Why? Let's explain here. You have one object like this on top, and let's say this is our angle is here, and or we can say 60, it's fine. Let's say 60, and then your gravitational force is coming down from here, people. Gravitational force. Let's finish our triangle here. It is maths paper 2, people. And this side you have normal force. What's that? F perpendicular, sorry, FG perpendicular. And this side FG parallel. Just I want to show you angle how it's worked. So it is 60, and then you have triangle here. So it's coming this side. What is this angle? You know it is 30, right? Because completing 90, you have 90 already, 180 total. And then this side is also 30. From maths, you know, just opposite, making cross here. If it is 30, this one is 60. As you see, FG is here, angle this side, angle with FG perpendicular. Because of that, we are using FG perpendicular is cos. Okay, FG perpendicular, yeah, it's here. FG perpendicular is cos. I hope it is fine. Just remember, if you have this triangle just inclined system, you are using FG perpendicular is cos, not sine anymore. Please don't do that mistake. And then FG parallel, if you are busy with Newton's second law, FG parallel is sine. All right. Okay, let's continue with solution now. Let's see. Okay. As you see, people, we have FG parallel is here, FG perpendicular that side. What we said, people, we are writing our Newton's first law. F net equals 0. And then what we said, forget about FG parallel. Why? Because we are busy only with F normal. What we have, let's use this side positive now, just up and down. Okay, it is positive, this side negative. What we have, it is here already, F normal minus FG perpendicular equals 0. It is coming from Newton's first law. F net equals 0. And then F normal equals FG perpendicular. FG perpendicular is here, equals FG times cos. Why it is cos, you know already, you understand already that, we explained, but remember, if you have inclined system, always F perpendicular is cos. Okay, from now, calculations. And what they said, not upward anymore, not north, not south, only perpendicular to surface. Perpendicular up also fine, but perpendicular to the surface. For normal force, if you say always perpendicular to for surface is fine. Okay, this question like this, I hope it is clear. I hope it is fine. So we calculate normal force for all types of questions. Okay, normal force, we answer for all cases. You know, all types of questions we have done. Let's continue with next question. Let's see what we have. I'm not waiting for you to write it down, people, but I will share this video with you, and then you can pause, you can just write it down. Okay, let's continue with next question. Let's clear all. Let's go to next one. Okay, now we are going to Newton's second law, people. Newton's first law, we have done for now, but for now, I'm telling you, because if you have friction force, we'll come back, we are gonna calculate normal force one more time. But for now, we are busy with Newton's second law. They said smooth surface. So it means no friction. Okay, no friction. If there is no friction, we don't need to calculate normal force. We are busy with only net force. Okay, so Newton's second law. How we are going to calculate this kind of questions, people? This is the one. First of all, you are going to say, I think we have a solution already. We are going to say F net equals M times A. It is here. F net equals M times A. This is Newton's second law. This is Newton's second law. After that, F net, what we have, people, only apply force, 10 newtons, equals 2 times A. And you can say acceleration equals 5 meters per second square. And then to the right, why? Because same direction of motion. So F net equals FF. If you have other forces, of course, if you have friction force, we are going to carry on with other things, but it is easy one, okay, for Newton's second law. F net equals M times A. F net is 10 newtons because only one force we have. After that, you are getting answer 5 meters per second square. That's it. I hope it is fine. Let's see any question from you. No question. We can carry on with next question. This is Newton's second law. Newton's first law is coming now. Sorry, next question is coming. Let's see. Okay, it is similar question. Your turn to try. Okay, someone with 75 kg, bicycle 25 kgs, force is 400 newtons, calculate acceleration. But please add mass. You need total mass. Okay, please try. Your turn. You have 2 minutes, people. On chat, I hope we are getting correct answers. Mass 100 kgs, force is 400 newtons, and then moving, please calculate acceleration. His acceleration, not her acceleration. Okay, please calculate. Let's see your answers first. I'm just waiting 5 correct answers from you first. Yes, number 1, I hope coming. Yes, number 1, 2. Let's make 5. Only 2. Please, people, please try. Newton's second law, F net equals M times A. That's good. Number 3 is here now. Number 4 is wrong. Not 5, not 5. Please double check. If your answer is 5 or 5.233, please double check. Because 400 newtons we have and 100 newtons, 100 kgs mass. Yes, more than 5 correct answers we have now and still coming other answers. That's good. Thank you very much. It means you are getting it. I'm so happy now. People, we are calculating with, yes, more correct answers coming. If you are getting 5, something, maybe you are using by mistake only 75 kgs, but please add mass, total mass we need, all right? And then you can fix it. Okay, let's go to next question. Newton's second law questions. I hope everything is fine. That's good. What they said, people, draw a force diagram first. Free body diagram still coming next, maybe next week we can carry on. So first of all, you are drawing F net equals 400 newtons. Total mass we are getting because we need total mass. After that, Newton's second law, F net equals M times acceleration. Acceleration equals F net over M total, 400 over 100, 4 meters per second west. So we cannot say west because not in question, they didn't say about direction. But what can we say? Direction of motion. All right, direction of motion is best answer for this acceleration's direction. All right, so Newton's second law, I think you are getting it, people. We start with easy questions. Let's carry on with other questions with friction. But now it's also easy because friction you don't have to calculate, it's already given. So what you are going to do, people, you are going to calculate net force. I'm sure you can give correct answer for this one also. First of all, you must get net force. How can we get F net force? F applied minus F friction. If F friction is not given, that is problem, which is difficult one. But now you will get F net because F friction is given. Please try this question also. And then we can show correct answer. You have 2 minutes only. Please try. Other question, we got more than 5, maybe more than 10. Let me count. 1, 2. Yes, more than 10 correct answers, 12 correct answers we got. I hope this one also given correct answers now. Our first answer is 2,5. I should check. Okay, let's wait to other learners' answers. I don't remember what was the answer. 2,5, another 2,5 we have. Let's see, 2,5, 1, 2, 3, 4. It means correct, huh? 2,4. You said 1, 2, 3, 4. Are you getting 2,4? 4? Please share with me if you're getting. one more correct answer from you. You are just getting net force, F apply minus, yes, another 2,5. It means it is correct. Let's see. Answer, I don't remember correct answer. Yes, your answer is correct. That's good. We have more around 10. And direction, yeah, only one learner sending direction. Direction is right. To the right, you are right. Okay, similar question, people. The other question, what we did, we add mass, we calculate total mass, but now we are getting net force. How we are getting net force, people? F net equals F apply minus F friction because of direction. You know what it is from grade 10, these questions. F apply minus F friction, 75 minus 12,5, 62,5 newtons. After that, Newton's second law. Of course, you don't have to write everything. Okay, just free body diagram. If they ask you, you are going to draw, but most of questions they are asking you, people. So free body diagram, if they ask, it is 2 marks question. I hope everything is fine. I hope you are getting it, people. Let's continue with next question. 3 minutes, yeah, one more question, and then we have done for today. Newton's first law, that was our aim today, people. Newton's first law and second law basic questions. We are trying to understand. I hope you get it. Let's continue with next question. Oh, it's finished. It was last one. Okay, we have that. All right. So let's check, just double check, people, quickly. We start with our normal force, Newton's first law. As you see, we have only object. There is no applied force, nothing. How we are getting it? We are using gravitational force, F net equals 0, and then we are getting our normal force. It is our first question for today. And then we carry on with apply force, but apply force pulling now. Apply force pulling, and then what we did, people, we are getting components of apply force, F parallel and F apply perpendicular, but we are using only perpendicular one. We don't need this side because we are busy with Newton's first law, and then only up and down because object is not going up and down. So F net equals 0. We just calculated. Other question, also we have F apply force, but pushing now. If it is pushing, direction different. Direction of perpendicular force is different. And then, people, as you see, F apply negative, Fg negative, and then you calculate normal force. Let's continue with next one. This system questions we did answer, people. As you see now, we have only gravitational force, but with only one point is important here. Fg perpendicular is not sine anymore. It is cos. All right, just remember this point, which is important one. And then what else we have? After that, you are just calculating it. You are just forgetting about Fg parallel one. As you see, Newton's first law one more time. But try to write F net equals 0 first. All right, so not just start like this. You will not lose your mark, but it's the best way. So F net equals 0. After that, Newton's second law start for today. Newton's second law, what is that? F net equals m times a. So we are using this one. F net equals m times a. So we have only apply force. And next question, a similar one. So F net is given. You are adding mass, Newton's second law. But last one, it was with friction force. From now, from next week, people, so next lesson, what we are gonna do, you will not have maybe a friction. A friction will be off, we don't know, for example, just cancel it. But you will have coefficient number, for example, 0.5. After that, how we are gonna calculate friction force, people? F friction equals coefficient number times F normal. You know already how can we calculate F normal, right? Fg and F normal, just like our question 1. I hope everything is fine now. So, you know, you are going to calculate nu times Fg because F normal equals Fg, nu times m times g. So you are going to calculate F friction and then other steps will come. All right. So that kind of questions coming with friction. And then for inclined system also coming with friction from next lesson. Inclined system also you will see with friction, but from now, people, similar questions you will see. Okay, Newton's first law, second law,